Hi, CP Algebra 1. This is our third video and lesson. This is solving linear equations number 3. Sometimes you have a variable on both sides. So remember, that's the letter. So you get a letter on both sides. And it could be the same, it could be different. We're going to deal with ones that are same right now. Later in the course, we'll see different ones on either side. But, we're dealing with this now. Hope you all are doing well. All right, so we're going to warm up with this. I know that most cell phone plans don't do this any longer, but it was a time that they would charge you by the minute when you would make a phone call. And I realize now with social media, things like that are much different, but it still gives us a thought process of how to do this. It says our cell phone bill is $59.40 for some month. Now, they're going to charge us $30 whether we use our phone or not. Okay? And then they're going to say, hey, we're also going to charge you 7 cents per minute. So 0.07, and we'll call X. We'll call X will be minutes. Okay? So as we use our phone, they're going to charge us 7 cents per minute that we use our phone for phone calls. Okay, so we want to go ahead and solve this. Remember what we were doing? We have this dotted line that represents the equal sign. So if I subtract 30 from both sides, I'm going to get on this side 0.07x. Those both cancel out. And on this side, I'm going to get 29.40. Now, before we had talked about getting rid of the decimals, multiply everything by 100, but I think we might be okay here, especially if we have a calculator to work this out. So how is 0.07 and x being held together? Yeah, that's right. They're being multiplied together. So in order to undo multiplication, I'm going to divide both sides by 0.07. And so if you have a calculator, take 29.40 and divide it by 0.07. And if you do that, you're going to find that we talked for 420 minutes that particular month. So 420 minutes, if you put that in perspective, divided by 60 would be hours. So it'd be 7 hours. They're not asking us to find the hours, but sometimes it's hard to think about how long minutes are in relationship to a day. So this is just kind of warm up and just get you feeling okay about this stuff. Okay, so remember our goal. When we solve an equation, our goal is to get the variable alone. And remember, the variable is the letter. Cool? All right, so we got some examples. So when we have the variable, the same variable on either side of the equal sign, we have to figure out what side we want to have the letter to be on. It doesn't matter if you move it to the left or to the right. You can always flip-flop your problem. So they have kind of a balance beam here. So whatever we put in this side, we have to put in this side to keep it balanced. Okay, and so you remember that the dotted line we do? That kind of just does that. So we have to think about what we would like to do in order to start this problem. And there's a lot of thoughts that we can do. We could subtract 2x from both sides. We could add 8 to both sides. We could subtract 3x from both sides. Or we could subtract 6 from both sides. And there's not really a right or wrong place to start it. I always like to start with the letters. So if we can move something over so a letter is not negative, that saves you a step later in the problem. So I'm going to decide to subtract 2x from both sides because it's positive 2x and those cancel. So then I get negative 8 is equal to 3x minus 2x is just 1x, or x. Remember, if x is by itself, it's a 1 in front of it. And then I'm going to subtract 6 from both sides because it's a positive 6. So I'm going to get negative 8, negative 6. See something that costs $8, something that costs $6. How much are you going to owe? You're going to owe 14. And as I said, this answer is totally appropriate. A lot of times we would want you to flip it over. And so I'm just going to write it over here to the side so we don't have this scale in the way. So we find that x is equal to 14. So if we plugged 14 into our original x's on the problem, you would wind up getting a true statement like 10 equals 10 or 6 equals 6 or something like that. Okay? So these problems are all going to be done the same way. I'm going to move this down. Okay, remember that that I'm using that as to indicate where my equal sign is. What I do on the left side of the equal sign, I have to do to the right side. So let's think. The last problem, we moved an x over first. Can we move a number over first? Sure, let's try it. That's going to give me a 6x over here equals, those canceled out, 8x minus 24. Now I want to get x by itself, so I'm going to subtract the 8x. And this is going to be one of those problems where if you don't move the right one right away, you wind up getting a negative x value, and that's totally okay. I mean, we're just going to divide by a negative here in a minute. Those cancel out, so I get negative 24. So negative 2x equals negative 24. Well, how are negative 2 and x being held together? Well, they're being multiplied. So I'm going to divide both sides by negative 2. These cancel out. X is equal to, negative over negative is positive. 24 over 2 is 12. So remember, you should be writing these examples down as we go along because there are problems that are embedded in this video that you can work on, and those count as your homework. So remember, the more of those you get right, the higher homework score you're going to get. And this is the third video, so technically this is your first homework that you should be watching outside of our class. I'm drinking myself a Dr. Pepper and cream soda. Pretty good. So if you hear me sipping on something, it's a Dr. Pepper cream soda mix. Pretty good. Okay. Excuse me. I guess I should have paused that, but I didn't. Let's see. So now I have a letter on both sides. I have my pink line that I've drawn in there. So I want to get the D by itself. So I'm going to subtract D from both sides. Remember, if I subtract D, that's the same thing as 1D. So negative 6D minus 1D, put a 1 right there, that would give me negative 7D, and then that's equal to positive 4. And negative 7 and D are being held together by multiplication, so I'm going to divide both sides by negative 7. Those cancel, leaving us just D on the left side. And that's going to give me negative 4 over 7. And this problem brings me to a point. So if we had this, or if we had this, or if we had this, it doesn't matter. Notice the negative is moving spots. As long as there's only a singleton negative, any one of those problems is right. And I actually was afraid to ask that when I was in school. And, you know, obviously as a teacher, there's certain things that I want to make sure I point out to you, because if I thought about it when I was a kid, maybe some of you might have thought that same thing, and maybe you didn't want to ask it because it seemed kind of funny. So I thought I'd cross that bridge for you. Okay, let's see, number 3. Okay, I'm going to draw my dotted line in. We want the letter by itself, so maybe I'll subtract m from both sides. How does that be? Those cancel. Subtract 5, or minus 5 on the left, and then 3m minus, remember that's 1m, is 2m. Divide both sides by 2, and so I'm just going to write m on this side because those cancel out. Negative 5 over 2. And notice I leave it as an improper fraction, meaning the top number is bigger than the bottom number. That is 100% appropriate. You don't have to convert things in my class to a mixed number. I prefer you keep it improper. Okay, let's see. Number 4. Again, we want to get the x, or excuse me, in this case, the k by itself. So I think if we maybe would subtract 5k from both sides. And you notice sometimes I move a letter, sometimes I move a number, and there's no rhyme or reason. I'm just trying to mix it up. So 7k subtract 5k is 2k minus 4 equals 16. Let's move the 4 over by adding it to both sides. Those cancel. So I get 2k is equal to 12. Divide each side by 2. Those cancel. And reduce. If we reduce 12 over 2, we get, that's right, 6. All right, last 2 problems. Again, there's my equal sign, and I want to get a by itself. So what do you think? What do you want to do? Let's just, for sake, subtract 5 from both sides. Is that what you maybe would have picked? I don't know. I bet you someone might have thought that, but so let's just kind of do it a little bit obscure order. It's still going to give me the same answer, which is kind of a beautiful thing with math. From here, I'm going to add 8a to both sides. Those cancel, so I get 5 is equal to negative 4a plus 8a. So that's like 8a minus 4a. So that's going to give me a 4a. Continue our little dotted thing. Divide each side by 4. So it looks like I'm going to get a equals, what is that, 5 over 4? And again, I left it as an improper fraction, 100% appropriate. All right, so let's take care of number 6. The only difference with number 6, yes, we do have a letter on both sides, but over here on the right side, notice this. I have two m's. So I'm going to combine two like terms before I start moving things over the equal sign, okay? So 7m subtract 1m, because remember there's a 1 right there, is 6m, and then plus 7. Okay, let's see what's going to happen here. I think I'm going to choose to subtract 6m from both sides. So that cancels and that cancels. So I get negative 5 is equal to 7. Did we just solve one of the great mysteries in math? Is negative 5 really equal to 7? Or does that kind of seem like it's nonsense to you? I hope you're saying it's nonsense, because we didn't discover some math anomaly to take place. Everything fell out. So does this make a true statement? Is this true? And I think most of you could say, heck no, that's not true. So this is not, and we're going to put no. And so if we put no, that means our answer is no solution. Okay? If that up here had given us something true, so if we had something like 7 is equal to 7, and all the x's are gone, that would mean we have infinite solutions. But in this case, we have something that's nonsense. We know that negative 5 is not equal to 7. So no solution for this answer. If that had come out to like being 7 equals 7 or negative 5 equals negative 5, then it would be infinite solution. So your answer to this one is no solution. Okay? Hope that's all right for you. Have a great day, everybody. Take care of one another. Bye-bye.